Hi guys, good morning. It's another lovely Thursday. I hope we're all doing fine. Okay, so of course we have a topic to treat today, a continuation of our previous class. But before that, I want you to just look at something. Okay, so we are still on mental math tricks. And our trick for today is using doubles for addition. Now this trick would be cool for you if you're familiar with doubles. Okay, so what does using doubles for addition mean? So let's take an example. We have 13 plus 17 now. Now instead of us to do 13 plus 17 directly, we can break that addition into doubles. So we can put it like this. We can say 13 plus 4. Okay, so like I said, if you're good with doubles, you can easily find the value of a number multiplied by 2 or a number added to itself. Then you can use this trick. Okay, so 13 plus 13 plus 2 plus 4, equals what now? So 13 plus 13 is, of course, 26. And then 26 plus 4 is what we have. So 26 plus 4 is 30. So automatically 13 plus 17 is 30. Okay, so that's how to use the addition, doubles for addition trick. Okay, so let's take another example. When we have something bigger, what do we do? Okay, for example, 72 plus 83. We can also use the same trick here. Now, break this down into 72 plus 11. Okay, so now you have 72 plus 72 as your double there. So you can now simplify that. Okay, 72 plus 72 is the same as 72 times 2. So easy. So this becomes 144 plus 11. And 144 plus 11 is simply 155. Okay, so that's that for using doubles for addition. Okay, so our answer is 155 here. Okay, so let's move on. We have a long way to go today. Let's move on. So sequences and series. We're still on sequences and series. Today we're going to be focusing on series. So look at this. Let's review quickly what we talked about in the last class. If you have forgotten any of the things we discussed, you can just quickly go back and watch the previous video and try to catch up before you watch this. Okay, so we started with arithmetical progression, and we said that the characteristic of arithmetic progression is that it's also called linear sequence, and the characteristic is that the term and the term immediately preceding it they have a common difference. So if you look at those numbers there, 5, 7, 9, and 11, you can see that the common difference there is 2. There. Yeah. So we also said that the general term, the nth term for an arithmetic progression is a plus n minus 1 bracket d. Okay, so that's the formula for finding any term in an arithmetical progression. Okay, now for geometrical progression, we said it's also called the exponential sequence, and then what we have there, the characteristic of it is that a term and any term immediately preceding it have a common ratio. That's the term can be divided by the other term, and then it leaves a common number that goes across that sequence. So in this case now, our common ratio in that example there is 2. Okay, 6 times 2 give you 12, 12 times 2, 24, and 2, 2, 2, 2, 2, on and on. So we also said that the formula for finding the any term in a geometric progression, we derived that formula. We said it's AR raised to the power n minus 1. Then we talked about the arithmetic mean and the geometric mean. So try to just remember and recall everything that we have said. Okay, let's now move to what we're going to discuss today. What is a series? When you say series, what does it mean? Okay, so a series is a partial sum of a sequence. So if you have a sequence T1, T2, T3, T4, and then it keeps going on and on to T of n, these are terms in a sequence, right? That means that S of n is T1 plus T2 plus T3 plus T4 plus up to the last term, which is T of n. So now S of n is referred to as the series. S of n is the series. It's the sum of terms. It's the corresponding series. Okay. Now let's move on. Sum of n terms of an AP. Now, okay, we've said S of n is the sum of terms or the series of a sequence. Now let's narrow it down to an arithmetical progression now. So AP, arithmetical progression. Let's try to derive the formula. As much as the most important thing is for you to know the formula and to be able to use it, it's also very good and important if you can know how the formula is obtained. Okay, so first term, we all know that the first term is A, the common difference is D, and the sum of n terms, as we have said, is Sn or S of n. Now let's try to make an equation. Let's try to form an equation. Okay, follow me. Now that simply means that our S of n, that's our sum of terms, is A plus D. Now A plus D is the second term. Hope you remember that. A plus 2D is the third term. So we just keep adding on and on until we get to the last term, which is T of n, and that gives us our first equation. Okay, that gives us our first equation. Now we can decide to also do the sum from behind. That is, we can decide to start adding from the last term. So T of n plus T of n minus D, that's the term immediately before the last term, plus T of n minus 2D, the term immediately before the second to the last term, and then we'll do that all the way down to the first term A. Okay, so we'll get two equations there, and that's what we have. Now, to now find our formula for S of n, we can now add these two equations together. We can add these two equations together. Now, if we do an addition, we're going to see a phenomenon where we're going to be having a repeated value across, across all the terms. So S of n plus S of n will give us 2S of n, right? Now D and minus D will cancel out. 2D and minus 2D will cancel out, and then that goes on and on until we get to the end. But you can see something remains, A and T of n, A and T of n, A and T of n, A and T of n. Okay, so A plus T of n goes on and on for n factors. So we can write this as 2S of n equals n, since it's going to appear n times. We can write it as 2S of n equals n into A plus T of n. Okay, into A plus T of n. So if we divide both sides by 2, we should have S of n equals n over 2 into A plus T of n. Okay, now this is one formula for finding the sum of an AP that is very useful. You can decide to actually use this if you need to use it. But we can also derive some other formula. Let's remember that T of n is A plus n minus 1 bracket D. So that simply indicates that T of n would be substituted into S of n. Okay, T of n would be substituted into S of n. So S of n now becomes n over 2 into A plus n minus 1 bracket D. I hope you're following. So that's what we have. Now, in essence, what we are saying now is that this formula can just be written as S of n equals n over 2 into 2A plus n minus 1 bracket D. Or, of course, we can bring back this formula and rewrite it here so that we know that we have two formulas. Now, if you see T of n or you see L, they are interchangeable. T of n means the last term, and L can also mean the last term. So you might see L used in some cases. Don't get confused. Okay, so let's now see how we can move further. Remember that we're going to use these formulas to solve problems now. We're going to use them to solve problems. So let's take an example of what kind of problem that we can solve using these formulas. So we have find the sum of the first 12 terms of an arithmetic progression whose first term is 10 with a common difference of 3. Find the sum of the first 12 terms of an arithmetical progression whose first term is 10 with a common difference of 3. So that's our question, and this is how to solve it. So A is our first term, and that is 10. Our common difference D is 3, and the number of terms we are to sum up is 12. Okay, so our formula should look like this, because now we know that we're not given the last term, so we cannot use the second formula that involves the last term. So it's your responsibility now to be able to, decide that, okay, I'm going to use the formula that has the last term and the first term, or I'm going to use the formula that has the common difference and the sum of n terms. Okay, so that responsibility falls on you, or lies with you now, to be able to decide which of the formulas you are going to use. So here we're using this formula. Let's move on. So we can now decide to substitute. So if we substitute, we should have 12 over 2 into 2 into 10 plus 12 minus 1 into bracket 3. So we should have something like this, and then we can move on. Okay, so when we try to simplify that, we should have S of 12 equals 6 into 20 plus 33. Of course, you know that 12 over 2 is 6, 12 over 2 here is 6, 2 times 10 here is 20, 12 minus 1 is 11 times 3, 33. So by the time we simplify this, we should have S12 equals 6 into 53. That gives us 318. Okay, so that's that for finding the sum of terms of an arithmetical progression. Okay, so let's go to sum of n terms of a geometrical progression now, a GP. Okay, so our first term is A, our common ratio is R, and our sum of n terms is S of n. We know that. Let's try to now look at the formula. How is the formula derived? Let's try to look at that. So we can form an equation for S of n using the sum of terms, right? So we say the first term A plus AR is the second term, plus AR square plus all the terms that lead up to AR raised by n minus 1, which is the last term. Now we need a second equation to be able to simplify further. So we're going to just try to multiply every term that we can see there now. We're going to multiply every term there through by R. So we're going to have something like this. R times S of n equals AR plus AR square plus AR cube plus AR raised to the power n. So that's how our second equation is going to look like. Okay, now we can now say that we're going to subtract equation 2 from equation 1. So if we subtract this, when we subtract this from this, or we say 1 minus 2, okay, we have S of n minus R S of n. Okay, and we have A minus AR raised to the power n. Every other thing in the middle cancels out, because AR, we take off AR squared minus AR squared goes out, and you get an AR cube here to take this out. Okay, you also get AR raised by n minus 1 to take out the last AR raised by n minus 1 somewhere here. Then you will just be left with A minus AR raised to the power n. Okay, so by the time you get that, you can factorize by looking for what is common. S of n is common here, so you bring out S of n, 1 into bracket 1 minus R. A is common here, you bring out A into bracket 1 minus R raised to the power n. So by the time you do all of this, you can now divide both sides by 1 minus R, and that gives you your formula here. Now I want you to take note that this formula that you just derived can only be used when the magnitude of the common ratio is less than 1. When I say magnitude, I mean irrespective of the sign, the value is less than 1. Then you can use this formula. But unfortunately, if the value is greater than 1, we cannot use this formula. We have to use something else. Now, that second formula we are going to use can be obtained by simply subtracting equation 1 now from 2. Instead of 2 from 1, we can subtract 1 from 2, and then we get the second equation that we can use. So if you do that, subtract 1 from 2, you're going to get, you can try it out based on what I've done for the first one. So you can try it out, you'll get this if you do it correctly. And then this equation, this one, the second one here, this equation can be used when the magnitude of the common ratio is greater than 1. Okay, so that's that for the sum of n terms of a GP. Let's now see how we can apply that formula. Okay, now the responsibility also lies with you here to know which formula to use. Okay, now we'll find the sum of the first 6 terms of the exponential sequence 18, 6 and 2, and then it keeps going on and on. Okay, so let's just say, what do we have? We have our first term A as 18, sum of terms we want to add together as 6, and the common ratio is T2 over T1, that's 6 over 18, and that gives us 1 over 3. Now you can see that our common ratio R, is less than 1 in this case. It's less than 1, so we bring the appropriate formula, which is the one that has A into 1 minus R raised to the power n over 1 minus R. Okay, so that's the formula we're going to use here. Now we substitute all our values. 18 into 1 minus 1 over 3 raised to the power 6 over 1 minus 1 over 3. So this gives us 1 over 3 raised to the power 6 is 1 over 7 to 9. Okay, 1 minus 1 over 3 is 2 over 3. Okay, so that's how we got that. Then this becomes 2 over 3 goes up and becomes 3 over 2 times 18 into 8 over 7 to 9. I think you know that 1 minus 1 over 7 to 9 should give us 7 to 8 over 7 to 9. Okay, maybe I'll teach you a trick one day on how to do those quickly, but let's see. So by the time you multiply all this together, you should have 7 to 8 over 27. 7 to 8 over 27. So that is that for our example on sum of n terms of a GP. Now take note that you will see variance of questions. You know, they'll be phrased in different ways. It's up to you to try to figure out how to answer the question, how to apply the formula, and just make the solution work. Now you need to try your best to put these formulas in your head so that you can recall them when you need them, and that's why it's important that you know how they were obtained, so it makes it easier for you to learn these formulas. Okay, all right, so let's go on to something else. Sum to infinity. Wow, infinity. You know what infinity means? It means something that goes on and on and on and on and on and on. Of course, our sequences so far have been infinite sequences. They've been, going on and on. You see the dots at the back, dot, you know that it keeps going on and on. Now, is it possible for us to get a value that, sums up this sequence to infinity, to that very, far distant term called infinity? So is it possible? Yes, it is, but there's a condition. So let's look at the condition together. Now, so first of all, there are 2 types of sequences in a broad term anyway. We have the convergent sequence. Now the convergent sequence is characterized by a common ratio that is less than 1. And what does it mean? It means the further along the sequence you go, you would be able to sum up the digits, or the terms rather, and get a specific value. Get closer and closer and closer to a specific value. So the sequence converges. Then we have another type, which is called the divergent sequence. I don't know if you've watched Divergent, but I don't think you're supposed to have. So the divergent sequence. So now the divergent sequence is characterized with a common ratio that is greater than 1. And what does it simply mean? It means that the sum of the sequence doesn't converge. It increases and increases and increases and keeps on increasing without a limit. Okay, it doesn't converge. Now, for a convergent sequence, you can find the sum to infinity. For a divergent sequence, that is not the case. Okay, that is not the case. So you might be asked, is this sequence convergent? Is it divergent? You should just be able to track the common ratio and observe from the common ratio if it's a convergent sequence or a divergent sequence. Okay, now, so the formula for sum to infinity of n terms of geometric progression that's for a GP that is convergent is, let's look at that now. So let's see the formula. So it's S infinity, that sign means infinity. S infinity equals to A over 1 minus R. S infinity equals to A over 1 minus R. Remember that R, magnitude of R should be less than 1. Magnitude of R should be less than 1. So r is less than 1. So our formula for sum to infinity is a over 1 minus r. Now, how do we apply that? Okay, how do we apply that? Find the sum to infinity of the sequence 1, 1 over 4, 1 over 16, 1 over 64. Okay, so our sum to infinity here is going to be easy, and I think this is quite straightforward. So of course our first term a is 1. Important, it's very important that you list out parameters so that then you can know what formula to use, or in a case where you already know the formula, it makes your work presentable. Okay, so a equals to 1. Our common ratio is t2 over t1 as usual. You can use t3 over t2, t4 over t3, but it's usually easier to use t2 over t1. So that's 1 over 4 over 1, which gives us 1 over 4. And sum to infinity would be 1 over 1 minus 1 over 4. Okay, so 1 over 3 over 4, and then that becomes 4 over 3. So when you hear sum to infinity, just think about the fact that you are finding the sum of n terms as the terms approach infinity. Okay, as the terms approach infinity, you know the meaning of infinity, something that keeps going on and on. You know that concept where in mathematics we say it's endless. Okay, all right. So let's move on. Now, this is the last part that we're going to look at, which is word problems. Now, geometrical progressions and arithmetic progressions, questions on them can come in form of word problems. Now, there's no need to panic, because I don't know why, but most of us do not seem to like word problems. I don't know if it's something that's associated with the fact that the word has problems in it. I don't know. I can't really understand. But I think what we'll do is this: if you don't like word problems, or you're not comfortable with word problems, now we can decide to just have a special class on word problems, and we'll look at it together. And then I'll after the class I'll ask you if you still believe they are difficult, because I don't think they are. I think if you have an average command of English, at least an average command of English, you understand English language, then you should be able to solve word problems, because all you need to do is break it down. It might not be easy at first, but when you keep practicing and you keep trying, you see at a point you begin to see patterns when you see word problems. Okay, so I want you to have this positive attitude towards every topic that you find, even when you don't like them. There are some topics I never clearly liked at first, but as time went on, I realized, I have to know you, so I just have to love you. And I realized that, okay, yeah, there's a bit of fun in this topic also. So we'll probably do that. Just let me know if I find out that so many of us actually have that problem, then I would fix a class for you guys, especially for that. So, but let's move on. Now, word problems. A tree is planted when it has a height of 2 meters. During the first year, it grows to a height of 3 meters, and its height therefore increased by 1 meter. Thereafter, the increase in height every year is 4 over 5 of the growth of the previous year. What is the maximum height the tree can reach? Okay, so let's lay out what we have. The tree is already 2 meters tall. Each year, the first year it grew by 1 meter. Then the next year it grew by 4 over 5 of 1 meter. The next year it grew by 4 over 5 of the previous year. So each year it was growing 4 over 5 times the previous year, right? Now they're not asking you what is the maximum height the tree can reach. Okay, let's look at this. So we have something like this: 1 plus 1 into 4 over 5. That's the increase in the first year is 1. The increase in the second year is 1 times 4 over 5. The increase in the third year is 1 times 4 over 5 squared. You can see already that this looks like a geometrical progression, right? Now, but since the question says maximum height reached, the tree can reach, it means we have to we cannot just say, okay, sum of maybe 5 times or sum of maybe 6 times. We have to sum the terms up till infinity, since we are looking for the maximum height. Okay, so in essence we're looking for the sum to infinity. So if you can understand what the word problem is asking you to actually find, then that's the bulk of the work. That's the bulk of the work. Okay, so let's move on. Of course, from this expression, a is 1. And our r is 4 over 5, and the tree keeps on growing and growing. So sum to infinity, of course, we remember that it's a over 1 minus r. So that will be 1 over 1 minus 4 over 5. That's 1 over 1 over 5. That's 5. Okay, now, but there's a temptation to stop here and say, oh, the sum to infinity is 5, so the maximum height of the tree is 5. No. The maximum growth was 5. It grew by 5 meters, even up till infinity. But the tree was already 2 meters tall. Or do you want to, take that 2 meters away from the tree? That's not possible. The tree was already 2 meters tall. There's nothing you can do about that, or there's no way you can get rid of that. So if it was already 2 meters tall, then the new height should just be the addition of 5 to 2 meters. Okay, so we're going to go get the answer now. So maximum height is 2 plus 5. That's all. That's all. Try to have a positive attitude towards topics that look very, very, very difficult. With time, and if you're persistent and you don't give up, you get it right. Yeah. Sounds cliche, but it's the truth. Persistent, you get it right. So let's move on. Now, I want us to quickly take a summary and then we can end the class. So we've talked about the series, and we've talked about the sum of n terms of an arithmetic progression. I was able to give you 2 formulas, and I said the responsibility lies with you to know which one to use at any given point. Then we looked at sum of a geometric progression, and again, the responsibility lies with you to know which one to use based on the magnitude of your common ratio. Then we talked about sum to infinity. We said there are some convergent sequences, there are some divergent sequences, and we said, okay, how do you know a sequence is convergent and divergent? You know that based on the common ratio also. So then we decided that, okay, convergent sequences, you can find the sum to infinity of those sequences, and we said the formula is, s infinity equals to a over 1 minus r, and then we use that in a word problem. Take note that the word problem I gave you, or I showed you, has sum to infinity indicated as something you need to find. It might not always be like that. You might have to find the sum of the GP, or the sum of the AP, or even the first term, or something else. So it's up to you to just try to understand what you've been given from the word problem, what hasn't been given to you, and what you need to find. Okay, so it's not difficult, and it's an interesting topic. Just try your best to practice more, and you get better at it. So in that light, I want you to practice some questions for me and give me some feedback in the comment section if you were able to get it or not. If you were able to get it on. So try these 3 questions out. Number 3, especially, we have what we call recurring decimals, where you have 0.12 and there's a dot on 1 and 2, that is 0.1212121212121212. So you can try to see if you can use the sum of infinity to find to express those fractions as proper fractions. If you're able to, let me know in the comments section. Okay, then you can also visit quizzes.com and see if you can find some games on sequences and series. Okay, so it has been so lovely, so lovely talking to you guys today. Of course, next week Thursday we would have another class on mathematics. Don't forget to like the video, share to your friends, leave a comment for me to see what you want me to see, and then subscribe for weekly updates. So I'll see you guys again next week Thursday for another interesting topic. Bye. Hi guys.